Okay, this will be the second video involving division of power series. Now, in the last video, we found the tangent of x by dividing the sine of x by the cosine of x and using power series. We'll do something a little different in this video. This time we're going to find the limit. Now, you might recognize this problem from something you had way back when you started calculus. You found the limit as x approaches 0 of the sine of x divided by x, a fairly common function. But to do this, you had to use the squeeze theorem. Now, the problem was this. If you take the limit as x goes to 0, both the numerator is approaching 0 and the denominator is approaching 0. And then it kind of becomes a race, really, of which one's going to 0 first. So if the numerator is approaching 0 faster than the denominator, then the whole thing would go to 0. If the denominator is approaching 0 faster than the numerator is, then the whole thing would go to infinity. And another option is, as x approaches 0, if the sine is approaching 0 at the same rate that x is approaching 0, then the whole thing will go to 1. And you use the squeeze theorem, if you remember that, to show that this thing was actually equal to 1. So we get a sneak preview of the answer before we get started. But it took the squeeze theorem to show that. Then another problem, we'll look at the second one we're going to do here. If you found the limit as x approaches 0 of 1 minus the cosine divided by x, and again, as x gets closer and closer to 0, the cosine is getting closer and closer to 1, so 1 minus 1. Numerator is going to 0, denominator is going to 0. And again, you use the squeeze theorem on this problem, and this time you showed that it was equal to 0. So let's do this, and what you're going to get in this video, and we'll go back to the first example here, is a much quicker way using division of power series to show this same thing without using the squeeze theorem. So let's take a look and see what that looks like. Now, first of all, this involves the sine of x. So the first thing I would do is just go to your tables of common function power series, and you should find sine, cosine, e to the x, and so on. Well, we want this sine of x, so my first step would be to just take this formula for the sine and write it on your page. So what I'll do is put that right here. So just write this formula for the sine down. Now what you want is the sine of x divided by x. So the first thing is to go ahead and do this division. So let's do that, and we'll put that, say, right here. I'll put it, a bar, it goes across. And I want the sine of x on top. So I'm just going to write the first few terms of this out. So this would be an x. Then I've got minus x cubed. And that's divided by, and I'll go ahead and put 3 factorial in its numeric form, so that'll be 6. Then you've got plus, then you've got x to the 5th, divided by, and 5 factorial would be 120, and then plus, and it goes on forever. So you're going to take this, and you're going to divide it by x, so you can have an x down here. And to divide this, all you do is just divide each term by x. So x divided by x would give you a 1, and then you've got minus, and then x cubed divided by 6 divided by x. The x cubed divided by x would turn into an x squared divided by 6. And then for the next term, again, x to the 5th divided by x would give you an x to the 4th divided by 120. And then you'd have minus or plus the rest of the terms going out. So what this is, this power series right here represents the sine of x divided by x. Now all you want is the limit of that. So take the limit as x approaches 0 of this power series. So you've got 1 minus x squared divided by 6 plus x to the 4th divided by 120 minus, and it goes on forever. And you put as many terms as you want to in there. But to find the limit, remember, in this one, as x goes to 0, any term that's got an x in the numerator is going to go to 0. So that one's going to go to 0. That one's going to go to 0. And all you will be left with is just this 1, so the limit is equal to 1, and you have showed this thing, but without using the squeeze theorem. So again, using power series, now that you're familiar with power series, is an excellent way to find some limits that earlier in the course might have given you some trouble, but using this thing makes them a little bit easier. Now let's do one more. We'll do a second one using the same thing, a common function. And this is one that you had before. The limit of this right here. Now again, a little sneak preview of the answer. This one's going to turn out to be equal to 0. And again, if you use the squeeze theorem, you can show that that's true. But this time we want to do same thing using power series. So again, go back to your list of this. This thing involves the cosine of x. So go back to your table of common formulas. The formula for the cosine is this. And again, my suggestion is just take this and write it on the page where you've got it in front of you. So we'll go ahead back to the problem and just write down the cosine. Now what the first thing we want is 1 minus the cosine. So I'm going to take 1, I'll put it right here, 1 minus, and for the cosine I'm going to write it in its power series formula. So this would be 1 minus x squared divided by 2 factorial, which we'll go ahead and change to a 2. And I think on all these, I'll go ahead and change those factorials into their number. Then you've got plus x to the 4th divided by 4 factorial, which would be a 24. And then minus, and it goes on forever. Now at this point, you can do this. Is 1 minus 1, these two terms are going to cancel out. So 1 minus 1, that will cancel out that. And then just distribute this negative. So that's going to change this into a positive x squared divided by 2 plus an x to the 4th. And actually that would change to a minus. That's going to be a minus x to the 4th divided by 24. And then it will go on with the other terms forever. So what this is the numerator. So now what you want to do is take the numerator and divide it by x. So let's go ahead and write this one down. I'll put a line across here. So in the numerator, you've got x squared divided by 2 minus x to the 4th divided by 24 plus, and goes on forever. And you're going to divide that by x. Well, when you divide this again, x squared divided by x would give you an x divided by 2. Then you've got a minus. X to the 4th divided by x would give you an x cubed. Divided by 24. Then you'd have a plus, and you've got the rest of it. So what this is, this right here, power series right here, represents the entire quotient. So 1 minus the cosine divided by that. Now all you want is just the limit of this thing. So in the final step, if you take the limit as x approaches 0 of, and just write this thing out. So x divided by 2 minus x cubed divided by 24 plus, and so on, and take the limit as x goes to 0. Well, again, as x goes to 0, any term that's got an x in the numerator is going to go to 0. So that one goes to 0, that one goes to 0, and in fact, all of them go to 0. So you wind up with the limit is equal to 0, and that's what you were trying to show up here. So again, using power series allows you to avoid the squeeze theorem and makes finding some of these limits that previously took quite a bit of work now actually become pretty easy. So just another use of division of power series.